everybody to this tutorial or short introduction to ShEx and entity schemas in Wikidata. I mean, we prepared this with Andra, Eric, Prud'hommeaux, and Harold, who are also here. So the first thing, just a very short overview of RDF, Sparkle, and ShEx, so you have the picture of where we are. So I understand that most of the people already know about RDF and the RDF data model, that is a set of triples, and you have several syntaxes. And here I added a very simple example of RDF in Turtle. This is a very simple social network where you have Alice that has a name which is a string and knows herself, and Bob knows Alice and has another name. And this example is in the syntax of RDF, which is called Turtle. There are other syntaxes. There is RDF XML, there is JSON LD, and there are several syntaxes for RDF. But I think Turtle is good for human readers, and it's interesting. And I also wanted this example to show that there is a tool that is called RDF Shape, and we are going to use this tool where you can put RDF data, and then you can check if it is well down, I mean, if it has the right syntax, and you can even show the graph that is generated. So here, for example, we have that information that Alice knows herself, Bob knows Alice. So this is the same information as here in the Turtle example, but represented as a graph. So this is just, of course, these are nodes that are in the graph. For example, Emily, that is not connected to anybody. That's why it appears separated. So that was a very short introduction to RDF, just to give an example of RDF, and because at the end, ShEx is a language to describe RDF. Then the other tool is Sparkle, which is also, I think, is interesting that the people who are looking at this tutorial, they know what is Sparkle, and probably you already know. It's a query language for RDF and also has a protocol. It's important to know that the protocol is what enables Sparkle endpoints. So you have you can put RDF data behind a Sparkle endpoint, and then you can do queries on that Sparkle endpoint. The syntax of Sparkle is very similar to RDF, because at the end is very similar. It's inspired by Turtle, but you add several keywords like select, where, variables, and this is an example of a very simple example of a Sparkle query where you select the name, the person, and the person who is known by this person, and then you have these triples. And these are called patterns in Sparkle. So if you click here also with the same tool, you can also play with it. And this is this example. This is the Sparkle query, and these are the results of the Sparkle query. So you can play with it. This is just to show this tool, because this tool, RDF Shape, is the same tool that we are going later to use to validate RDF data. Okay. So that was the short introduction again to Sparkle. Now, okay, so probably maybe in 2013, in the semantic web and the applications of semantic web, most of them had a lot of RDF data, and most of them also provided that RDF data behind Sparkle endpoints, and that's the situation. And probably nowadays, a lot of solutions also have that. What are the problems that we are trying to solve with ShEx shape expressions? I mean, the same for me, as when I jumped in 2013 into this problem was because I was also working with data portals. So we have a lot of RDF data. We wanted to publish that data, and we just wanted to document the data that we were publishing. We wanted to have a tool where you could say to the consumers of that data what was the RDF data content and how they could do some queries on that data. And that seems easy, and that's an easy question to do, but it's not so easy to do. At the end, it's a little bit difficult. Most of the typical Sparkle endpoints, they are the documentation is maybe just what they use is just a set of examples of Sparkle queries. But those examples, maybe they are good and they are well documented, but that's usually not enough. You need something more rigorous and more where you really know what you have here in this Sparkle endpoint. So that's when I was looking for something else. I met Eric and Harold, and we started to try to define some language that was easy to describe this RDF data. If you describe it, you also can validate if the data conforms or doesn't conform to that description. So that's why for me, ShEx, which is the next slide, is a language to describe and also validate RDF data. You can do several other things with these descriptions, but for me it's important this definition is. So ShEx can be used to validate, and in fact that's also a very important application, but the beginnings of ShEx was to describe RDF data. The syntax again is inspired by Turtle and Sparkle. Yeah, and it has two features that I think they are important, is that we intended the language to be human readable, but at the same time to be machine processable. So you can, those descriptions that humans can understand, at the same time they can be processed and they can be validated, and you can check if the RDF data conforms or doesn't conform to those descriptions. So that's the main idea or the main motivation for ShEx. And this is an example. So maybe if you are new to ShEx, this is an example that is trying to describe the previous content, the previous RDF data. So in the previous RDF data, if you took a look, you could say, okay, we have some nodes. Those nodes have a property which is the name and must be a string, and then they know other nodes that, so this is a very simple example. So you have those nodes, we could say that the shape is the shape of a user, and they know other users. And notice here that we have this star. This star is the cardinality, and it means 0 or more users. The last point here is that we also can say that these nodes, in this case, should be IRIs. So they should be, we don't allow, for example, blank nodes, or we just assume that they should be IRIs. And this example, again, with this same tool, if you click, I mean, the slides, maybe Andra, you can put the slides in the channel, in the chat, so they can look to the slides. So this is the sample and the link. So here, this is the shape expression, and this is the RDF data. This is the same RDF data as before. And now this is the result of validating. So we are validating. In order to validate, there is a third part, which we call shape maps, where we say which nodes we want to validate against those shapes. This is also a very simple language, and it is much more expressive than this. You can put here all the nodes that have a type user should conform to the shape user, or other things. I mean, there are other things that you could even put here a Sparkle query and say, give me all the nodes that have some kind of arcs, and I will validate those nodes with this shape. Okay, so that's another possibility. And here, with this example, we can check the results. For example, notice that they are not ordered, because at the end we are talking about graphs, and graphs, you have arcs, and the order of those arcs is not relevant. So for example, if we have Alice, in this case, Alice conforms because Alice has a name which is a string and knows herself. So we assume that she is a user. Bob knows Alice, and notice here also that the order, I changed this order also on purpose. And here we say that name and knows, but Bob knows and name, but that is not relevant because we are talking about arcs. So in this case, it also validates. So Bob is here and validates. And in the case of Carol, she doesn't validate because she has two names. So notice that here we said that she should have only one name. So that's why I'm here. If you click on details, probably it answers what was the error, or tries to explain why it failed. Then we have Dave, which has a name which is an integer, so also it also fails. Emily has notice that it has a name which is a string, but this comes from FOF, which is a different namespace. So it also, in this case, it also fails. Emily fails. Finally, we have also Frank. Frank, in this case, has name and knows Alice and Bob, so he knows other users, but has another property. And there is no problem because by default, the shape specifies the properties and the values of those properties, but allows to have other properties. So if in this case, we have another property, which is email, so there is no problem with that. And in this case, Frank validates. In some use cases, some people could prefer, for example, to specify that only the properties and the values that appear in this shape are the properties which are allowed. If that's the case, you can put here a qualifier closed. You put closed, and if you put here closed, we can play with this. We say that this is closed and try to validate. Now, for example, which was Frank. Now Frank is not validating, but I don't see Frank. Because here I hadn't added him to the save mark. So we try to validate Frank. And now Frank doesn't validate because it is closed. And if we remove the close, it will, Frank now validates. Okay, so you can see how it is possible to validate these things. And this is a very common thing. I mean, this is very common. There is, I don't know if maybe I can explain another thing that you will find in several samples is that imagine that you want to say, for example, the user must have one type, for example, the type of a schema person. So let's play with this. Maybe you want to say that, I mean, you know that the A is the same as RDF type. You can put RDF type, and then we should put here prefix RDF. Notice well here in this tool you also have autocomplete, so you put RDF and it goes to prefix CC and allows you to autocomplete. So we are asking to say, okay, so users should have the type of person. Now all of them will fail. They should fail. All of them fail. But if we start declaring prefix, well, we can do the same with an A. You can use a schema person. Let's do only with the first two ones. Person. And then if you click on validate, now Alice and Bob, they validate. And sometimes people say, okay, but that's maybe too restrictive. I mean, I want to ensure that they have the type of person, but maybe I could allow other types. For example, imagine that you want to say that Alice is a person, but at the same time has another type. For example, let's see that she's a teacher. So she's both a person and a teacher. If we put this data as it is now, Alice is not going to validate because she has in the definition of the shape, we said that she should only have one type, which is person. So this is a very common pattern, and the solution here could be to say, okay, but I want to allow extra values for the RDF type. So I want to ensure that she must have a type of person, but I allow extra values for that type. And let's try it again. And now Alice validates and Bob validates, but the rest don't validate. Okay, so those, I mean, this is a very short introduction to ShEx. And of course, if you want to know more about the language, so if you want to know more about the language, I think I couldn't avoid this. We wrote this book, and so if you are interested, you can can follow this link. Of course, you can buy the book. I appreciate that, but the book, the contents of the book all the contents are available in HTML format, and you follow this link, and you could, if you scroll down, you can go here and you have the introduction to shape expressions with all the features of language one time. Okay, so that was the short introduction to ShEx. I don't know if you have any questions, Gayo, or if you want me to finish. I have 2 or 3 slides more where I wanted to say what was the use of ShEx in Wikidata. So I don't know, do you want me to continue, or do you have some question? Maybe I was very fast. Okay, if there is no question, maybe I can continue, and then at the end we can start talking about the different use cases and all that. Okay, so let's continue. So that was ShEx. So as you can see, ShEx, it is not just ShEx for Wikidata. So nowadays the ShEx is used by Wikidata, and that's a very interesting use case. But you can use ShEx in other situations where you have RDF data and you want to describe that data. So if you have Sparkle endpoints and you want to describe the contents of those data portals, and you want also to validate, then you can use RDF. In fact, when we started with RDF, with shape expressions, we were not applying that to Wikidata. That came after that. Okay, but then Wikidata, and that's the nice thing, is that Wikidata, I think it's not necessary to introduce you to Wikidata. Probably you already know what is Wikidata. I just copy the definition that they have in the web page. It's a free knowledge base that anyone can edit. And yesterday, at least, they had 90 million data items. So it's a big knowledge base. The nice thing is that they provide this Sparkle endpoint, and you can do Sparkle queries to Wikidata. So nowadays it works. This is a Sparkle query that I did this morning, where I was asking, let's try it, see if it works. I was asking about, so these are people, and this is the occupation, researcher. This was a country of citizens, it was Spain, and the birthplace. So I obtaining researchers that has the country of citizen Spain, and I obtaining the birth date and birthplace. So this is just a very simple Sparkle query that you can play with this Sparkle query. Okay. Then what happened? What happened is that in 2019, last year, Wikidata adopted shape expressions. They call that entity schemas, but at the end, the language used by those entity schemas is shape expressions, is ShEx, and they have this new namespace, which starts by E. There are probably you already know that there are other namespaces. The most popular are the Q, which is for entities. So, for example, in the previous Sparkle query, this was an entity, was the Q. So this was the Q is Q29, and followed by several numbers, is by several digits. This is the item of Spain. And then there are other namespaces, which are, in this case, are the properties, and the properties start by P. So P27 in this case is country of citizenship. And so they created a new namespace, which was E, and this E is for entity schemas. I have to say also that in Spanish it's called a schema, it starts by E, so for us it's very good. In English, sometimes people would prefer the S, but the S is for senses, so it was already reserved, so that they used entity schemas. And for an example is here. So let's go click to E42, and this is the entity schema of author. So you can see this is in Wikidata. Okay, and now this is an example of a shape expression that defines the main properties that an author can have. So, for example, we can say that we have P31 notice that they are using the extra. That's why I explained before the extra, and they also have this P31 instance of whatever. I have to say that I don't like very much the current interface of Wikidata to show this, because this doesn't have syntax highlighting and all that. So that's, I mean, I recommend if a tool that we developed in our working group is WikiShape, and in this tool you can see the same thing. So if you click on information about the schema, it was author. You also have here autocomplete to search for schemas. You can obtain the information, and now here is, I think it's better because you have this, when you hover the mouse, you can see what is the meaning of the different numbers, and that's, I think it's very useful, because, for example, not everybody will remember. I mean, the P31, I think everybody who works in Wikidata already knows about that, but for example, other numbers is impossible. The Q5 is human, so for example, this is saying that the author must be an instance of human at least, because we have another extra P31, which means that authors could also be instances of other things. And then we also saying that they must have a given name. They have this gender, which in this case doesn't have a restriction. It says any IRI. This is the occupation, and the occupation, I think this is going to be author, the item of, which sometimes it takes a bit to autocomplete. Okay, it's no, writer. So the occupation is writer, etc. So as you can see, these are the shape expressions that define, in this case, the schema of authors. And then once you have that, you can validate. So you can go here, and there is this link here, so you can click and you can use it to validate. So if, for example, this were about authors, the way to validate, I mean, there are other ways to do it, but with this tool is that you can do the Sparkle query here. You can go, we usually do, this is like a typical pattern is that you go here, you put some sample queries, and you put those sample queries here. So we are obtaining people that have this occupation, and in this case we put a limit of 5, because at the end there are a lot of them, and otherwise it would maybe do a timeout or something like that. So that's why I usually put a limit. So let's run the query to obtain the entities to check. You obtain the entities to check, and it didn't validate yet, but then you start validating, and now if it's green, it means that it is validating. Okay. Of course, we could play with this. We could change, for example, whatever. Let's say that the instance of must be instance of Q23. That I don't know what's that's a random thing. And now none of them validate. Okay, so you can play with this interactively to define your entity schemas. Okay, so and that was the introduction to entity schemas for Wikidata. I had this slide because this slides I was doing this slides in another event, and I had in these slides, and that's the link for this biohackathon. I had these 4 reasons why using entity schemas was useful. I had, for example, they are useful to describe the schemas of sets of entities. What are the properties that you want to use, the possible values, the constraints that you want to enforce. You may want to validate entities to say if they conform. You can filter some entities that conform or don't conform to those schemas. Yeah, at the end, the main goal is to improve the quality of Wikidata. I mean, in Wikidata, we have 90 million of items, and it's growing. Not all of them have the right quality. So at the end, that's what we want, to improve the quality. But I added this for this biohackathon, so this is just new. And this is what we are trying to do in the project 35. We are trying to use taking as input those entity schemas, those ShEx descriptions. At the end, as I said, with ShEx you can describe data, and that you have that description. With that description, you can create a subset of Wikidata that maybe is useful for you. I think in this case, that's probably a lot of you are researchers. I think this is very, very important if you are doing research on Wikidata or Sparkle endpoints, and you want that research to be reproducible. I mean, nowadays, you know that there is this trend that they want your research to be reproducible. And if you want your research to be reproducible, one problem if you are doing research on Wikidata is that it is a moving target. I mean, Wikidata is continuously changing. You could obtain a dump of Wikidata, but that's something which is not easy to do. But if we have an easy way to create a snapshot of some interesting subset of Wikidata, I think that would help the people who want to do research on Wikidata. So that's one of the motivations of the work that we are trying to do in this BioHackathon. So I don't know, so this just was an example, and maybe I think I was talking too much already, and I wanted to have some questions. So this was an example of an entity schema of hospitals, but I already did that with authors. So this is, you can click here, you can see the entity schema, you can validate the entities. So this is the same thing that I already did. You can do a Sparkle query and validate the entities that you obtain from that Sparkle query. And this is the sample of validating hospitals that we have already done. This is the Wikisave tool that I have shown already. The Wikisave tool sometimes is also useful. Let me go. This Wikisave tool. Okay, this tool sometimes is also useful because here you can also visualize entity schemas. For example, one entity schema that we are working in this hackathon is the gene wiki. That this is the entity schema that we are using as a as a running example in this biohackathon. And this is, I mean, the previous entity schema was very simple, but this is a bigger one. So this is an entity schema where, I don't know if you can see it, I can maybe increase it. So you have proteins, the proteins have this link that I don't remember, I think it was part of binding site. They also have this link to molecular function, another link to gene. The genes have a link to biological pathway or to biological process, to chromosome, etc. So you can see. So this comes from with that Andra and other authors made about using Wikidata as a platform for fair data. And they defined this data model, and that's the data model that we are using in this as a running example. And this is the data model that we are trying to obtain a subset of Wikidata that contains information about this shapes. So, for example, we have about taxons, symptoms, diseases, etc. But that information should come from Wikidata. So that's the idea, is to obtain a snapshot of Wikidata that conforms to this description. Okay, that's what we are trying to do. Yes. Oh, I went to the first slide. Sorry for that. So this is Wikisave. Yes, I was saying, I was going to show how you can use Wikisave to visualize entity schemas, and this is the gene wiki entity schema that we are using in the biohackathon. And just to finish, there are some tools that, I mean, this is the Wikisave tool that I have been showing, and the RDF shape. Those are the tools that have been made in the research group, in Western research group. And the difference, they are very similar, but the difference is that the Wikisave one is tailored to users of Wikidata. So it has some predefined or some built-in assumptions about the endpoint that you are going to use and all that, while the RDF shape is more general and it's for any RDF on any endpoint. So if you have already a Sparkle endpoint and it's not Wikidata, you can use RDF shape to play with it. There is this editor that I was using that has autocomplete and all that is José. There is another tool is ShEx Author. It was made by one of my students. It's like a visual editor of shape expressions, but this is just a proof of concept. We also have this tool which is called ShExer, that it comes by a need of the users that they asked us if they already had a Sparkle endpoint with a lot of RDF data, how they could start to create shape expressions for that existing data. And so this tool is allows you to extract automatically shapes or shape expressions from existing data. And I think this is a very useful tool. I have to confess that I hadn't thought about this tool until I was talking, I think, with Andra, and Andra told me that they needed that. I mean, they already had a lot of data, and they wanted to generate automatically the shapes from that data. And there is also this Shape Designer. This is another tool that allows to do this more or less the same thing. ShEx Statements is a tool to automatically generate schemas from tables. And ShExLite is also another tool to do something like that. And just before this this slide, just before this tutorial, I was talking with Harold and Eric, and we thought, okay, maybe we could also present other applications of ShEx in real life that are being used, not only for Wikidata. And this is a collection of several applications. Maybe we can just talk a little bit about them, or I can just let Eric and Harold to explain them, because fire was probably the first motivation that went to ShEx was fire. And okay, so do you want Eric to explain this a little bit, or Harold?
Yeah, I don't know how many people here are familiar with FHIR. It's fast healthcare interoperability resources, and it's become the de facto standard for exchanging clinical data in the medical space. And FHIR has 3 exchange formats. It was first spec'd in XML. There's a JSON format, although interestingly, they've never completed JSON schema. It's just JSON templates. And the third format is RDF. And we emit shape expressions for validating the RDF. One of our goals in FHIR is that it actually has a whole bunch of embedded modeling languages. It's based loosely on UML. So for instance, it's got an internal language that is kind of like OCL, and it's our hope that once we have all the shape expressions complete, we're also going to unify the language rules. The 2 things we've got up there, just a sample shapes expression that you can pull off of the FHIR server. And then there's a Jupyter notebook, just an example of how one uses it to validate FHIR RDF.
Okay. And that's also the gene ontology that we all know that they are using also shapes. And there's this BioLink that you know also, Harold.
Yeah, the BioLink markup language is one that's been being used in some of the translator and other projects. It's a YAML-based language that then emits OWL, JSON, RDF, and other things. And this is just a sample here. The BioLink model is emitted by the BioLink modeling language. It's the shape expressions model for BioLink.
This DTL maybe comes from Eric, no?
Yeah, I just changed that underneath you because I like to keep you on your toes. It should be DDI now, in fact. But I guess you have to restart the thing to see that. So that's the data description initiative. It's these, they have a very comprehensive model for representing data, statistical data. And so the link there is just to a cute little HTML interface that's generated from the ShEx that comes out of their workflow.
Okay. So that's, I think, some of the tools. I mean, I didn't put here a link because last week I did a tutorial in the International Semantic Web Conference. The tutorial was ShEx applications and tools. I will probably add the link later. And in that link, I also collected several other use cases, but other use cases, for example, in our research group, we are applying ShEx expressions in other domains, not in bio domain. But for example, something that we are doing, which is very related with this work on the gene ontology, is that we are using ShEx expressions to validate the contents of an ontology. So we have an ontology, this is an ontology for research, and we also define several ShEx expressions that define the state of that ontology, and we also have some test data. And we connect all that with a continuous integration server, so you can validate the content of the ontology before and after inference. So you can check if there is, for example, imagine you have data about a researcher, and you say the researcher have a type of researcher, and then you have in the ontology that researcher is a subclass of researcher is a subclass of person. Then if you apply the inference, the reasoner, you should infer that that specific researcher should also have the type of a person. And we connect all that with a ShEx expressions that validates the ontology. So we are using test-driven development for the ontologies, and we have this continuous integration. So in case that when you are defining either the ontology or the test data or the shapes, you do some mistake, the continuous integration server will tell you that you did that mistake. So this is something that we are currently using. We are developing a framework which is very similar to this Jenkins or Travis that shows you the different builds and the different errors. And that's another application that I just forgot to put here, but maybe it's interesting for you.
I should probably add that that ShEx is showing up pretty prominently in Solid's workflow as well. So that when you describe when you build a Solid, which is a basically personalized linked data repository, when you build one, the stuff we're building on top of that to manage it and keep the data consistent, like a thing called shape trees, is using ShEx a lot.
Yes. Okay. So in the case of implementations, there are implementations in these languages. I think in JavaScript, the author of the JavaScript, the main author is Eric. The main author of the Scala implementation is me. The Python one is Harold. So you have here the three authors of these implementations. The Java implementation was done by Jovka Boneva, and there is another one, Ruby and ELIXIR and Haskell. So also, I think if you have any question about ShEx, probably you have the key people here, Harold and Eric, to ask them about questions. And I think that's all. I added this slide in case that you have a typical question that people have. Maybe with this slide we can open some kind of debate or some questions and answers. Some people say, okay, but if we already had Sparkle, why don't we use Sparkle to validate? And the answer is, okay, yes, you can use Sparkle to validate. And in fact, in 2017, when I met Eric, I was proposing to use Sparkle to validate. But this slide comes from Eric's slides where he said, okay, the Sparkle is very expressive, and that's a good point. But that's also a bad point, because maybe it's too much expressive, and sometimes if you want to express some validation constraints, which are usually very easy to do in ShEx, you have a very long Sparkle query. So this is an example of this Sparkle query. I mean, it's not very well edited, but you can, so this is a similar Sparkle query that validates the ShEx schema that I was using as an example before. This is not the same, because I notice now that this is validating that you have a name which is a string, and you have the gender. The gender must be male or female. But for example, this is not validating the users. I mean, user knows another user because that's recursive. And Sparkle, plain Sparkle doesn't have recursion. So that's an example why Sparkle is, I mean, can be used to validate, but maybe it's not the right tool to validate. Okay, so that's it's a very common question that people have. And when we were before this meeting, we were saying maybe we should include these slides. And that's the end of the presentation for that I had prepared. And maybe now, if you really have any question, just do it. I think it's the right moment.
Actually, I just want to throw in one more point. If you go back to the last slide,
yes.
When you've got the ShEx for that, it's quite simple. Somebody can look at it and understand what it is. But when they look at that Sparkle, it doesn't serve very well to communicate to somebody what the structure of something is. So the other argument against the Sparkle is that once you write it out in this hugely long verbose format, you haven't actually told anybody what the structure is. You've only kind of told the computer how to test that the structure isn't its sound.
Yes, that's true.
There were some questions in the chat. I don't know if we want to run through that or whether we would like to, whether the persons asking the questions in there would like to ask it live. And maybe I should start. There was a comment, and that Frank was already not validating. I guess this was when you were going through the example. Yep. And there is this question about shackle and the relationship with ShEx. Can you elaborate about that a bit?
Yeah, I mean, that's a very common question. I think I already have, as I said, I did a tutorial about this last week. So I will put the slides of the tutorial here, which has much more things to do, but, and then I will, so the tutorial, this is the link. Okay, so I will put the link in the chat also. I mean, because I have a lot of things to do, and maybe it's difficult to do a short overview of all the things that we can say about that in just this tutorial, this meeting. The thing is that, I mean, there are several common things between ShEx and shackle, but on the other side there are also different things. Let's go for the common things. Both have a very similar goal, which is to describe and validate data. But I think shackle is not so much to describe, but to add constraints to data. So the difference, and I think that's like a philosophical thing, but I think makes the difference because with ShEx, you are describing what is the data, and you are interested to know what is the data that you are having, and then you can use that to validate. But with shackle, you are more, you have the position that you are saying what is the data that you don't want. So you say, okay, yeah, I want to put some constraints on the data, and I don't want, for example, a user to have a name which is an integer. So that's a constraint. So that's something that you want. So that's why in the working group, the people that were more proposing in shackle, they were thinking more about what were the errors that you were going to obtain when you were validating and how to define those constraints. So one main difference is that, I mean, is that in shackle is more constraint oriented, and ShEx is more oriented to define like a grammar. So that's one of the differences.
Can I jump in real quick with one? Oh, and an analogy that might work for some people is XPath is schematron versus XML schema. Schematron gives you a bunch of integrity constraints you can run over your data, and XML schema or RelaxNG both give you effectively the equivalent of a BNF or a grammar for your data. And so you can think of shackle being like the schematron list of rules, and ShEx as being like XML schema or RealActionG, which is a structure for your data.
Yes, yeah, exactly. I mean, yes, exactly. Yes, so for me, ShEx is more like a grammar, or like where you define what you want, and then there are several technical things that may be interesting, because some people say, okay, but Shackle is the W3C recommendation, ShEx is not a W3C recommendation. That's true, ShEx, but ShEx is being developed by a community group in W3C. So we are, I think Harold, Eric, Andra, and me, we are in the working group, and so this is a W3C community group that we are working on that. But there is a technical difference, which I think is important, is that Shackle, as it is right now, doesn't support recursion. So you don't, for example, the previous ShEx that I had at the beginning, the first ShEx that I had here, where you have a user knows another user, if you try to translate that directly to Shackle, you could represent that, but that would be outside of the current Shackle, or the recommendation of Shackle, because Shackle in recommendation, and I think that was one of the stop points that the people who were more working with ShEx, we didn't want to have a language that didn't allow this kind of cycles. And these kind of cycles appear constantly. I mean, when I was using here the example of, for example, this example of genes and chemical compounds, etc., has a lot of recursion. For example, biological pathway points to itself, so maybe it's part of another biological pathway or whatever, and you have genes are related with this arc to biological pathways, and the biological pathways are related with genes. So you have these cycles, and these cycles in Shackle are not allowed. Okay, I mean, they are not allowed in current Shackle. I expect that there will be some in the future, some version of Shackle that they will allow that. But at the point of the W3C recommendation, it wasn't. So people who are using Shackle and they are using recursion, they should know that they are not using the W3C recommendation, because what they did is, it is not forbidden, but it is something which is implementation dependent. And for example, I noticed that I was using in RDF shape. Also, if you want to play, you can also play with Shackle. I mean, I didn't see that. So that, but you have here RDF shape. You have also a tab. So you have ShEx, and you also have Shackle, and you can play with. You have several examples here of Shackle. So let me show an example of Shackle. So this is a similar example in Shackle. So you have a user shape, but notice that the syntax is a bit longer, because the syntax of Shackle is also turtle. Is RDF, is not a compact syntax. They also have a compact syntax now, but that compact syntax is not part of the recommendation also. In this tool also, you can play here with different engines. So I included here the Jena Shackle. Apache Jena now has support for Shackle, and there is the top quadrant. But for example, the Jena Shackle, if you put here, for example, that a user shape knows another user shape, you have recursion, then it has a Stack Overflow. I mean, it's just so it doesn't work. It doesn't support in recursion. Okay, so and it conforms to the recommendation, but doesn't support recursion. So yes, there are a lot of other things or other points in this comparison, but I mean, I don't want to seem to that I'm just criticizing Shackle. Shackle also has some good points, but I think this is a different thing. For example, with Shackle, the work that we are trying to do to create subsets of Wikidata would be different, in my opinion.
Okay, I just want to throw one last point, that the sort of the design of ShEx, which was sort of from a greenfield, like what would be easiest for users to use, allows for people to reuse each other's shapes without having to go and communicate with the people who are off of those shapes. And frequently in Shackle, if you create a shape and then somebody wants to extend it, they have to contact you and say, can you rewrite that shape, or even refactor it out to use a different shape, and et cetera. So that you end up with a lot more. You end up with a lot more centralization in that process.
Yeah,
Okay, moving forward into the comments. There was a suggestion by Thomas Lehner where for your slide that they are using ShEx in the BioHack COVID project. There is a link in there, which is covid19gnetwork.org. And then there is a question from Eric Antezana. Could you comment on the performance of ShEx while dealing with large data sets, e.g. a few million triples?
That's a good question. I mean, that's something that we are. I mean, I want to work on that. So that I want to implement my current validator. At the end, is doing Sparkle queries to those Sparkle, and sometimes it's not very performant. So I mean, there is the complexity. The theoretical complexity is MP. I don't remember exactly, but it is theoretically is very complex, but most of the use cases doesn't go into that complexity, and they could have some optimizations, and that's currently part of my research work. I mean, that's what I'm working on. Also, I think Eric and Harold were working on that. So it depends on. So there are strategies that we could take to optimize our validators that we didn't take yet, but that's a work in progress.
So I could also throw in from the fire perspective, there was a kind of going to the shackle thing. There was a validation that we ran with ShEx Java, and with we sort of turned to crank and produced some shackle for something as well, and ran that with, I think, the top quadrant shackle engine, and it was 1,000 times faster with the ShEx. It was just off the scale faster, and it was because the model, what the machine was doing was really dedicated towards testing the structure rather than running a whole bunch of complex queries that would execute testing the structure.
Yeah. Also, because you can do. I mean, you have this the sample before. Not this. If you have something that like this data model that you have cycles and you want to validate, of course you can try to put all the data model in memory and try to validate, and that's what we did. My implementation did at the beginning was to do that. But there are other strategies. For example, you know that you want to validate this data model, and you have, for example, go to genes, then you go to taxons, and then, but you can have some kind of cache where you put the nodes that you have been validated until now, and you can do the validation in a lazy way, not trying to put all the nodes in memory, but trying to only put the nodes that you are validating at that moment, and have some kind of cache as a secondary memory where you put the results that you already have been validated. So there are a lot of strategies that until now I didn't have time enough to work on that, but that's, I mean, I'm here. If there are some people who are researchers and want to join forces with us, that would be great. I mean, I think there is a lot of room for optimizations in the validators. Yeah.
Maybe to add to that, when I'm running shape expressions on data that's coming from Wikidata, and I'm not dealing with a few million triples. No. And the issue there is that the performance of running the entity schemas in various applications is similar to the ETL script. So if aligning an ontology with Wikidata costs 8 hours, validating that it is exactly 8 hours, but that's mostly driven by the infrastructure provided by Wikidata, being the API. So it's from that perspective, it's hard to say. So that's actually also why why we're working on the subsetting, because we want to get that that API or the infrastructure constraint out of the way, so we can work on because for now dealing with the existing infrastructures where we cannot create subset, the performance is like the usual API traffic that we see with other pipelines.
Yes. I don't know if Eric Antezama, you want to say something about that or?
Yeah, no, first of all, thank you for the nice presentation. And really, I didn't know a lot about ShEx. I mean, thanks for the introduction. Maybe you remember we discussed a little bit about it in one of the last BioHackathons in Japan, but I didn't have the time to look into some more detail, let's say. But now I'm really excited. I would like to try it out. And as I just mentioned in one of my last questions, in the second question actually, we have a few million triples in our internal triple store, and I was of course interested to increase the level of the quality of the things we have. We are exposing a Sparkle endpoint, of course, and then we said, yeah, this could be an opportunity to get it to, let's say, put it into the next level. So I will be definitely connecting to you, José Emilio, to the other guys, I mean, to the other experts, with maybe a little bit more of questions of if there is a chance to get a different session, so that I could also explain to you in a bit more of detail what I have internally, and that if you could give me some tips, let's say, how to implement this kind of technology. But yeah, thanks. And maybe one more question, if you guys have still a couple of seconds, what do you guys have in terms of the future developments for ShEx? I mean, you just mentioned that you are busy working with performance. Any other improvements? Any other things on which you are working on?
Should I go through the laundry list?
I was thinking about maybe extends.
Yeah, well,
exactly. That's what I was going to say. I mean, Eric has an implementation that supports extends. The concept is similar to inheritance in object-oriented languages, where you have, imagine that you want, for example, that you have the shape of a person and you want to have the shape of a researcher, and you want to reduce the shape of a person, but just adding other properties. So you want to have inheritance. And that's a very intuitive concept. And Eric's implementation already has that. He has been...
ShEx Java has it now too.
Sorry?
ShEx Java has it as well.
Yeah, ShEx Java has that. And I was working with Eric, I think it was 2 years ago. And I promised him that I was going to implement that. But I mean, the time passed very fast, and I was planning to do it this week, but probably it's going to be next week. But yes, for example, the extents and inheritance is one of the things that it's also going to be very important, because at the end, I think something that I noticed now is what I called shapes ecosystems. So, for example, in Wikidata, you have an ecosystem of shape expressions of schemas, and you want to relate. So there's a link. Maybe you have that link, Andra, about the entity schemas in Wikidata. You know that they have a classification of the entity schemas and all that, and that's very interesting, because someone just put a classification of the different entity schemas and how some entity schema depends on other entity schemas. So you have like this whole ecosystem of shape expressions, and I think that's a very natural path forward. And I think if we have this kind of extents, that's going to be very useful. So,
yeah. Another thing we're working on that is kind of important. A thing to realize about shape expressions is while we tend to use the term validate naturally, it's actually predicates that simply tests collections of triples or data sets for conformance. And sometimes it's good to go either direction, but we're working on, I'll call it compartmentalization and pruning. The notion that if you have a set of triples, you want to check whether they conform to a particular shape, a person's shape or an issue shape, and mark them as conforming or not conforming, or remove that set of triples from the set of the whole collection of triples being tested, and go on. And they're going to be using that in Wikidata, particularly just to not only say, do you conform to a particular Wikidata model, but to actually make suggestions saying you should really fill in this little bit here, or to conform to the Wikidata model, you might want to add this triple.
That's also very interesting. I call that the usability of shape expressions. How to improve the usability of shape expressions. And I think Dan Brickley said to me once, for example, that if they are planning to use this, for example, for validating in schema.org, they want to be like the parrot, and then, so I mean you want to give a price if you conform. If you have data that conform, you obtain a price. But if you have data that doesn't conform, you want to have some kind of warnings, not just say, okay, it doesn't conform and you are out of the game. So you just have some kind of middle ground. So you have between errors and full conformance, you have warnings or suggestions, these kind of things. Yes,
the semantic implication of a warning is that if I'm testing something and then it requires me to test something else, and that other thing throws an error, then the first thing is invalid. Whereas if the other thing throws a warning, then the first thing can still be valid.
Yes.
I wanted to throw through two more things quickly that we're talking about adding. One was uniques, which is the ability to have keys that for simple scenarios, be like, I want to make sure that no two SCOS languages labels for something have the same language, or for more complex things, I want to make sure that everybody in this database has no two people in the database have the same social security, that kind of a thing. Another one is graph. Right now, all the validation happens within a single graph, but there are various various mappings that people have between graph names and the subject node of interest in that graph name. Sometimes it's the same name, sometimes it's got like a hash on it and stuff like that. And so having ShEx that would traverse, that would validate a data set rather than just a single graph, I think would be a very useful step forward. And we've got some designs for that.
Another thing is that we still didn't, I think I remember the first paper that we wrote about shape expressions shape expressions was as a description, validation, and transformation language. And something that ELIXIR implementation also supports that, but the part of transforming, for example, now that in this exercise that we are planning to do, that we have Wikidata, we want to obtain a subset of Wikidata, but maybe at the same time that we obtain that subset of Wikidata, we want to transform that. I remember that, the ShEx implementation support semantic actions, and in those semantic actions, you can do some kind of mapping or transformation of the RDF data that you are validating. So it's not just validating, but also generating data that has been transformed from that RDF data. That's something that is already there, but I think we didn't use that enough already. I don't know, Eric, if you are using that, but I didn't have still a use case or a real need to use that.
So Eric, understand, is there a feature you're looking for specifically?
Well, the question was mainly in curiosity about what are the next, let's say, improvements that you guys are going to perform. And of course, it was quite extended to what I originally expected. But I don't have, let's say, a very concrete or specific need nowadays. As I just mentioned, we have an internal triple store where we have a couple of millions of triples. And as I mentioned, what I would be really willing to do is to bring it to the next step and increase the quality by including, improve the description, validation. And as I mentioned, I'm very curious to start using ShEx and to see how it will not only perform, because that was another question I had around the performance, because it's a large amount, but this doesn't mean, of course, that we have to run it in real time in some certain cases. Although part of the mechanism we have is we have what we call an internal synchronization of different triple stores, so different repositories. So for that particular use case, perhaps it could be interesting to have, let's say, like a bit more of performance, of course. That's why I was interested in that particular topic, for instance. But I think some more questions will be coming up once, of course, I will start using it.
Maybe I would. Yeah. Maybe we could find a table in the balcony in this and discuss. But I also want to use the opportunity to mention the community group. We have a community group. We meet twice per month, and anybody who is interested in discussing use cases or suggestions is welcome to join.
Are we meeting this morning?
That's a good question. I thought we didn't, but we could decide to do so. That's up to, what do you think, Eric, Jose? Should we?
Should we have a CT meeting?
Let's have this offline discussion.
Yeah.
And are there other questions that want to be raised now, or should we call it an hour and then continue the discussion in the margin of the BioHackathon?
I just wanted to say that I noticed that Anastasia is here with us, and when I was talking about the use of schema.org with shape expressions, I was thinking about the work that she has been doing for Google. So she's here. So maybe you can even put a link, Anastasia, here if people are interested. So that's.
Yes, and the question on not so domain, but to change. So I was working on me and then.
So it was called Schemarama, right? So
yes, and it's for
okay.
validation schema.org related data with ShEx. Yeah.
Okay.
Thanks for the link. Should I take all of the links that people have dropped into the chat and paste them into the end of the slides? Because people already have the links to the slides.
I think that's a good idea.
Yes, a good idea.
Because Labra just been talking about ShEx map, and so I dropped a link to that, and I've dropped a link to the extend examples, and Guillermo just dropped a link to Anastasia's work on Schemarama. So lots of good stuff in there if you guys want to dive into the bottom of the slides.
So and then I think I call it the end, but I won't leave the meeting yet for you to copy. But I'm stopping the recording now. I would like to thank the audience for their attention, and I'm looking forward to talk to you in the BioHackathon. And you can always, we are at table 35. You can always come along and just pull us aside to discuss any topic related to ShEx. And that's it. And thanks, Jose, for a very nice presentation.